In this video, we're going to learn how to sketch a graph of a function by looking at the zeros of a given function. We're also going to be able to determine the end behavior and the type of function we have. So here we're giving a function that is already in factored form, and we know it's in factored form because I have one number times a binomial times a binomial. So I have three numbers being multiplied together, so that's factored form. Before I get ahead of myself, I want to make sure that we understand what the words zeros mean. So if you think of zeros, this is actually a nickname for where y equals 0. So y has to equal 0 in order to find the zeros. Some other words that mean zeros is roots, x-intercept. The x-intercept is where y is 0. And then we also have the solution of the function. So all these things mean the same thing as zeros, okay? But this is most critical right here where y equals 0. So that means that y then becomes 0. So we're actually looking at this as 0 is equal to x times x minus 3 times x plus 5. So in order to find the value of x, we set everything, each factor, equal to 0. So my first factor is x, so x equals 0. That's one 0. The other one is x minus 3 equals 0. So I want to solve for x, which means I add 3 to both sides of the equal, and I get x is equal to 3. And then here, I set my last factor to 0, solve for x, which means I have to subtract 5 from both sides of the equals, and I get x equals negative 5. So notice I have 3 zeros. So let's go ahead and sketch this out. So I need to have, when I sketch, I need to at least have some semblance of an xy axis. So remember, my x-axis is where y equals 0. That is the same thing as my x-axis. So let's see, I have x is 0, so x is 0 right here. So that's the point 0, 0. X is 3, so we'll do 1, 2, 3. So that's the point 3, 0. Let me write this out like this. This is the same as 3, 0. This is the same as 0, 0. And this is the same as negative 5, 0. Because remember, we're doing x-intercepts. So negative 5 would be 1, 2, 3, 4, 5. So this is where x is negative 5. This is where x is 0. And this is where x is 3. So I know that my function is going to go through those points on the x-axis. Now I'm getting a little bit ahead of myself. There's this thing called multiplicity, which we can then determine by looking at this. But let's just try to figure out what kind of function this is. So if I were, I'm just going to do a little bit, let's do this down here. If I had x times x minus 3 times x plus 5. If I were to multiply this out, I'm going to see that this is a third degree polynomial. And I'm going to partially multiply it out just to show you. So notice if I distribute that x into my first number, I get x squared minus 3x. So I'm not going to fully multiply this out. Actually, I just changed my mind. I think I'm going to. So I'm going to multiply this out now. So I'm going to put x plus 5 here, and I'm just going to go ahead and do it in an organized way like this. And this number here is x squared minus 3x. So when I multiply to the inside, x times x squared gives me x cubed. That's going to be my highest degree. Negative 3x times x gives me negative 3x squared. X squared times 5 gives me 5x squared. And negative 3x times 5 gives me negative 5x. So again, for those of you who've been multiplying using this method, there is my peanut of math. Those are actually like terms. So I'm going to write down my first term, which is x cubed. I'm going to combine my like terms. 5x squared minus 3x squared gives me a plus 2x squared. And then I have a minus 15x. So we can see that the highest degree is 3. So this here is a cubic. And it's also odd. And it's also positive. The first term here is positive. So remember what I said about positive functions. Positive functions have something like a positive slope. So I know this is a positive slope. So I know that this side is going to go down. And this side, kind of in my work area, is going to go up. So that means that this is going to go up through here, down through here, and up through here. So I've just sketched. So this is here is a sketch of x cubed plus 2x squared minus 15x. Notice I did not put any scale on my y-axis because I have no idea where this maximum or this minimum is. I'm just kind of guessing, so that's a sketch. So the last thing I want to point out here is I do not need to multiply all these terms together in order to figure out what degree it is. Let's look back here at my initial. Actually, I'm going to look up here at the top. So if I were going to write the degree of this x, it's a degree 1. This x is a degree 1, and this x is a degree 1. So all I have to do is add up the exponents, and that tells me what degree function this is. So 1 plus 1 plus 1 is 3. So from here, I can simply get that this is a 3-degree polynomial.